Okay, so let's have a look at this question. The velocity of a car in t seconds for the first 20 seconds is given by this formula. Now, that tells me that the velocity is variable. Okay, so we can't use Savat here. Acceleration is not constant, but k is constant. Now, when t equals 20, the acceleration of the car is 1.3. Okay, and then anything after 20 seconds, car continues that journey with a constant acceleration. So that's Savat. Now we can use it after 20 seconds until it first reaches the speed 25 meters per second. Right, okay then, find the value of k. Now the first thing is, what you could do is, it's told you when t equals 20, acceleration is 1.3. So what you could do here, when you got v equals kt plus 0.03 t squared, if I do dv dt, take the power down, take 1 off the power, that will be k. Take the power down, take 1 off the power, and that will be 2 times 0.3 is 0.06, sorry, t. Now, when I put t is 20, the acceleration is 1.3. So this is, don't forget, dv dt is, I should have said that earlier, is acceleration. This is the rate of change of velocity with time. So acceleration is 1.3. K plus 0.06 times, when that's 1.3 when t is 20. So if you put that through your calculator, you should be able to do that. 10 times that is 0.6, double it is 1.2. 1.3 equals k plus 1.2. Take that to the other side, therefore k has to be 0.1. So now I know what k is, and I know that's fine. I'm done with that. Now it goes here, find the total distance traveled when the speed reaches 25. Now, because I know what k is, I know that v is equal to 0.1 t plus 0.03 t squared. Now, that is the velocity. In order to find the distance or displacement, what you do to velocity is you integrate it respect to time. And if you want to know what is the distance, you put the limits in. Well, it started from it starts from 0. If it hasn't stated it, I'm just saying velocity of that of the car first 20 seconds. So that goes from 20 to 0. So if you use your calculators, press the integration sign, write 20 to 0, and put in 0.1 t plus 0.03 t squared respect to dt. Now, you're not going to get any extra marks to show that integration skill, so can you all do that on your calculator now? And a brief soul, shout it out. You should have got 100. So that will give you 100 meters for the first part of the journey. Now, the second part, because the second part, you've got A is constant at 1.3. You don't know what T is, you just know it's greater than 20, but you do know that, actually, you do know the final speed is going to be 25. Now, what you could do here, because you know what the velocity is, you could find the initial speed. So the initial speed would have been 0.1. Now it starts from 20, this formula, so 20 plus 0.03 times 20 squared. So you get 2. That is 400. 400 times 3, 12, So that's 2 plus the 12. So the initial speed was 14. That is the final speed. That is A, and I want to find out what is displacement. Okay, so I've been given A, U, V, and I want to find S. So what formula can I use? I can use the formula V squared minus U squared equals 2AS. So if I rearrange that, first of all, that will give me 25 squared minus 14 squared equals 2 times 1.3 times S. So if you get your calculator, you'll get 625 minus 196. You'll get 9, 5, 1, 2, 4, 4, 2, 9, and if you share that by 2.6, anybody?
165.
So that displacement will be 165 meters. And that the first stage was 100 meters. So the total distance, therefore, total distance is going to be 100 meters plus 165 meters. You get 265 meters. So that's your final answer. And that is it.